Good morning, everyone. Today we're going to continue our discussion on data structures. We're going to finish our discussion on our example on data frame. Okay. So last time we ran this code chunk. We created this vector called ID, which is 1 to 200, group consisting of repetition of the word vehicle 100 times and drug 100 times. And then response, which is randomly generated with a mean of 25 and standard deviation of 100, and also 100 where the mean is 23 and standard deviation is equal to 5. So all in all, 200 observations consisting of 3 variables: ID, group, response. So we're going to create this object, my data, and we will make it a data frame. We'll rename the ID vector as patient, the group vector as treatment, and the response small r as big R. And we set that seed to 1, 2, 3, 4 so that we have the same values. So we ran this last time. Let me rerun it. So there we can see here the vectors group ID and response, and then we can see here the data frame my data. So we have this. There are 200 observations. The first 100, the treatment is vehicle, and then you have your response here. This is normally distributed, the first 100 with mean 25 and standard deviation is equal to 5. The second 100, mean 23 and standard deviation 5. All right. So last time, what we did was to do a subsetting. Okay, we will not run this anymore. The head will just give us the first the first 6. Delete this. It's just a repetition. 6 observations. We can identify how many observations. The length of a vector of a data frame will give us the number of columns or the number of variables. The dimension will give us the number of rows and columns. And okay, we know what the structure function will give us. It will give us the type of data structure, the number of observations, and the number of columns. And then the type of data. Here you have integer, character, and numerical for the 3 variables. The summary will just give us the the 5 number summary if it's numerical, and if it's character, just the count. So if it's factored, then it will give us a frequency distribution. Okay, so last time what we did was to learn how to subset. Here we're creating an object called x1, and then we are subsetting my data. So the use of these brackets tell us that we want to, the first number here is the row position. The second number is the column position. 1, 2 means first column, first row, and second column. So if we take a look at this, my data. So, sorry, what did we look for? First row, second column. Okay, my data. First row, second column, that should be vehicle. The intersection of the first row and second column. And if we ask also for the class, then we can see that the value is vehicle, and it's the character, which means that it's a vector here. So the subset of a data frame can be a vector. So here, the same thing, 2 and 3, second row, third column. Now, what about if it's several rows and several columns? Okay, so let's run this. X3 is my data. We'd like to generate the first 20 rows and the second and third columns. So let's run this. Okay, and we can see that X3, let's take a look at the output here. So this is X3, which consists of just 20 observations, right? 20 rows. And then it consists of the second and the third columns, treatment and response. Now, this is not the patient. These numbers 1 to 10 is not the patient. It's the index, the row index. In fact, if we take a look at the, let's see, let's generate the X3 object here. You can see here that we only have two columns, the treatment and the response. You have the row number here or the ID, but you don't have the patient here. Okay, so we learned last time also how to use the subset function. Okay, so let's create, for example, this object X for A. Okay, and it's my data. Then, sorry, let's use the subset function. We learned about this last time. Subset, and we're subsetting my data. Okay. And okay, last time what we did was, okay, let me skip that for a while. Let's go back to what we did here for the subset function. Okay, okay, we had an example on this. Okay, here subsetting vectors. Okay, that's from the base package, and we had some examples here, right? So here we have subset of the object air quality, which we discussed last time. And then we are selecting columns. Okay. So here we identified that the rows should be, why don't we run this so that it's clear to us? Let's repeat this, Control C, and then let's run this in the console, and let's create an object, or let's call it S1. I think we also used S1 last time. But before that, anyway, okay. Is there anything missing here? S1. Okay, one. Missing one. Okay, I'm missing one close parenthesis. Okay, so I created this object S1. Okay, it consists of 68 rows, and then I have ozone and temperature. But let's see the original data. View air quality. The original data has 153 rows and 6 variables. So what we did in this code was to subset it, okay, by the basis was temperature greater than 80. So we're subsetting the rows. We're using temperature as our basis, and we're saying that all those temperature that has greater than 80, that's greater than 80, that will be chosen. And the select function is used to identify the columns that we want. Okay. So select for the column, and then if we want a particular rows, then we have to define it. We can define it using the column, okay, patient greater than 80. Okay, in our case, let's go back here. So this was my question to you before. If we want, okay, So for this one, for X4, we generated this object where we have the first 20 rows and then all the columns. Okay, or for X3, we generated the first 20 rows and only the second and the third column. So why don't we generate X3A? So we're going to use the subset rather than the brackets. This is more robust. Okay, so using the my data. So what's our my data? This one. We only want the first 20 rows. So we're going to say that patient should be from 1 to 20, right? And then we only want treatment and response. So how should we do that? How should we subset? Okay, we can use here our patient should be greater than or equal to 20, less than or equal to 20, right? So that's our patient, only from 1 up to 20. And then we can use the select function to only include, just like this one, right? Select, sorry, not parentheses, but select is equal to, we have what are the okay, we have treatment and response. We have treatment and comma response. Okay, let's see if this will run. Okay, so we're trying to replicate the X3 object, which is 20 rows, and the second and third column or variable. Okay, let's see X3A. So we now have an object here, X3A, with 20 observations and 2 variables. Let's see if it's similar to your X3 object. All right. So we have here 20 observations and your response, corresponding response. So is this the same as X3? Let's see. Vehicle 18.9646. Yeah, it's the same. So we were able to recreate X3, name it X3A, and then not use the brackets, but rather use the subset function. Okay? So the subset function is a lot more powerful than just using the brackets. Okay. Right, so let's continue with the subsetting. Okay, so in this next codes, we're still using the brackets, but I will leave you guys to experiment on how you can do this using the subset. Anything and everything here can be done using the subset function. So same thing here, my data, and then the response is greater than 26. And nothing here means that it's all the columns. Okay, so let's run this. My data subset, and then the response greater than 26. Why don't we give this a name? Let's call this S4 so that we can check. S4. Okay. So let's run this. And let's see, you have S4 here. There are 59 observations. And we expect that the response should be, all responses should be greater than 26. Let's see. Okay. There. All the responses are greater than 26. There are no responses that are less than 26. Okay, same thing. Now, what about if we do not include my data, because we already specified that this is my data, and then we're subsetting it. Let's name this S4A. Alt minus. Will this run? So my data, and then we do not include response. Let's see if this will work. Control Enter. All right, S4A. Okay, here. Response greater than, okay. Response greater than 26. And you notice there are 200 observations, S4A. Okay, and it's not the same as S4. S4 only has 59 observations. So response greater than 26. Let's see S4A. Okay. So it still included everything. Okay. And the response is not greater than 26. So this is exactly the whole of my data. Okay. So it did not filter. Okay. It did not filter. If I, on the other hand, let's try to see, if I do not include the quotes here, what will happen? Okay, I did not include the quotes. Will this run? So we run it, and it did not run. It says here error, response not found. So this was not found. So even if we already stated here that it's coming from my data, this did not run. Okay, let's try. So putting here the quotes did not run either. And here generated the whole my data, okay, data frame, right? And put here some nodes. Control C, Control V. On the other hand, this one, error, okay, did not run, did not recognize response, okay. So even if we already identified that it's from my data data frame, it still did not recognize this even here, okay. So it did not filter, it did not subset. All right, so let's go here. Next is okay, let me, why don't I separate this? Okay. So let's call this S5. Let's generate another data frame. S5 is, okay, you have my data, and then we know that we have to put here my data treatment. It should be equal to vehicle. Okay, only the vehicle, and then my data dollar response, it should be less than or equal to 23. So what do we have here? The presence of and here requires that both conditions have to be met. Okay, so it should be vehicle and the response should be less than 23. So this is for the row and this is for the column. For the column, it should include both, all the three variables. So if we run S5, Control Enter. All right, then let's take a look at S5 here. Okay, S5. Okay, first, it includes all the variables, which is correct. We did not filter, we did not subset the variables, everything there. And then all the response should be less than 23. Okay, if you survey the data, take a look at the data, there are 50 observations all in all, where your response is less than or equal to 23. Okay, so it run. Okay, so if you want, so here, both conditions have to be met. The use of and means that both conditions have to be met. Let me just close some of this. Okay, so that I don't have okay, many tabs here. All right, next, let's create now an object called S6. Let's just give our data frames a name. So same thing, treatment is equal to vehicle. And this one, the this is called the pipe. Okay, this vertical bar here, or the pipe. It's coming from response, and the response should be greater than or equal to 21. Now, this means that both any of the conditions have to be met. Okay, so it means that all the vehicles will be included, and this means that any response that's greater than 21, not whether or not it's vehicle, should be included. So if in X6 you expect that all vehicles will be included, and all response that are greater than 21, vehicles and not vehicles, the drugs will be included. Okay, so okay, let's run this. Okay, why don't we? Okay, let me change this just to compare it with this one. Okay, so let's compare it with the first one. The difference between this is that this is and, while this is or. So we expect that this S6 should be more in terms of number of observations than S5, because S5 just restricts it to both vehicle and less than 23. The response to be less than 23. So both conditions have to be met. On the other hand, for this one, it should be vehicle or the response is 23. This indicates that all the vehicle will be included, and this indicates that all less than 23, whether or not it's vehicle, will be included. So let's run this S6, and then let's take a look at S6. If you notice, S5 has 50 observations, S6 has 149 observations. So it's more, okay? And as expected, the first 100 are your vehicles. So for your vehicles, even if it's not less than 23, okay, for example, this is 27, it's still included. Okay, and also for the drug here, okay, even if this is not vehicle, for as long as it's less than 23, for as long as the response is less than 23, then it will be included. Okay. All right, so we can see the difference between these two. Now, how about this? Let's create another object called S7 here. S7. So it's the same, my data, the treatment. Now this means not equal to vehicle, or my data is greater than 24. So this means that not equal to vehicle, which means all treatment, okay, all treatment that's not vehicle will be included, which means drug. Okay, all drug treatments will be included, or my data response greater than 24. So even if it's vehicle, it will still be included for as long it's greater than 24. Okay, so this will mean our data frame will consist of vehicles and non-vehicles. Okay, vehicle and drug. It will include all drugs, the 200, the 100, and then it will also include vehicle for as long as it's greater than 24. So let's run S7, Control Enter. All right. So we have here S7 is 146 observations. So it consists of, okay, it will also include vehicle, but it should be greater than 24. So if you take a look at vehicle, it includes those that are greater than 24. And then for the treatment drug, okay, from 101 up to 200, they're all included, regardless of whether the response is greater than 24 or not. Okay, because the code is This one. Or all right. Okay, here I think we're including. Okay, here we're creating this object called age. Okay, and then we're rounding it off. We're using our norm. Okay, we have to set, if you want to have the same values, okay, let's just set that seed 1, 2, 3, and then we create this object, age, 200 all in all, mean is 40, standard deviation is, let's make standard deviation equal to 10, all right? And then, what's the object of this? Okay, so let's run this. What we're doing here is we're including. So this is how to include a particular vector, particular column in your data frame. So we're creating this object called age. Okay, it's made of randomly distributed numbers, 200 all in all, with mean 40 and standard deviation 10. And then here, my data, $ age. So we're creating this variable in my data, and it's equal to the age vector here. And then let's see how our my data looks like. Let's run everything here from set.seed, control enter. And then here you can see our my data. Here, my data now contains an object, a vector, a column called age. We have added that column here. Okay, so let me pause for a while. Are there any questions? Clear ba so far, class, yung discussion natin? I leave you. Thank you. I leave you, class, to discover this one. How do we do this? We can do this using subset, of course. Okay. And it's easier using subset. This one. Okay. All right. So let's go now to dates. Okay, date is one of the most important object in or data type in as far as finance is concerned. And we know dates are written in several ways. Okay, so for example, we have this one. We're creating this object called X, and it consists of this one. You have here the codes 623, 2013, etc. You have here 3, and then let's get the class of this. Okay, you can see that this is character. The presence of the codes there would indicate that it's characters. All right. But if we are interested, okay, to make it dates, okay, as we said here, R treats the vector X as character. Now we would want to coerce it to become dates. We can make use of the Lubric package. So kindly run this, install that package, just Lubric. I will not run it anymore because I have already installed it. Rather, I will require the package. So let me go here. Okay, I can just run this, the library or require Lubric, but I'll just to illustrate, I'll go here and type Lubric. Okay, Lubric there. Lubric. Okay. Then maybe let me check if there's an update for this. Let me see. Lubric. packages. Okay. You can update here and see if there are any updates. The version I have is 1.9.0. I'm not sure if there is a Lubric 1.9.0. So the most current version is 1.9.1. Okay, take a look at this. Plus, I updated it. So it tells me that I have here packages that need updating. May mga packages ako na what I installed are not the most current. So I'll just do that next time. For now, let me just update Lubric. Okay, I'll click this and then install updates. Okay, I can restart it. Yes. In your case, most probably you don't need to update it because maybe you haven't installed it, right? Successfully unpacked. And then if you take a look now at my Lubric date, it's now 1.9.1. Okay, it has already updated. And then let me require this. I'll click this, and you can see here that the automatic code is library or require. Okay, so it says here, attaching package Lubric date, the following objects are masked from package base. This means that there are these functions date, intersect, set, diff, and union that can also be found in the base package. However, it will be masked, okay, which means that Lubric date and base share the same, they have the same functions. But what will prevail now will be the Lubric date function for date, intersect, set, diff, and union. Okay, it will, if I use, for example, date, it will use the Lubric date package and rather than the date function in base. Unless if I want to use the base function, then I will have to type, for example, base, double colon, and then date. There. If I want to use the date function in the base, in base R, then I will have to type this. Okay. However, the default will be from the Lubric date. Lubric date. Okay. As you can see there. Let me close this. Lubric date, double colon, and then D. Okay, you can see here that there's also the date function in Lubric date. So when I attach the Lubric date package, it says here that the following objects are masked. Masked means when you just use this function, date or intersect or set or union, it will follow the syntax of Lubric date and not base. Okay, I hope that's clear. Okay, so let's go here to dates. All right. Okay, here, the best way to get Lubric date is install the whole tidyverse package. Okay, there's this, I'm not sure if I already, kindly do this, install that packages, and then please install tidyverse. Okay, so let me do that also. Anyway, install that packages, tidyverse, control, enter. So I'm installing tidyverse, although I have had that already. Nothing wrong with that anyway. Okay, here it says the package tidyverse successfully unpacked. And then let's use library, then tidyverse. Library tidyverse tab. Okay, let's run this. Control enter. Okay. Notice when we loaded tidyverse, okay, it tells us that it will come with these other packages. So tidyverse includes ggplot2, table, tidyr, readr, per, dplyr, stringr, forecasts. Okay, it also includes lubridate. Okay, and as I mentioned a while ago, there's this difference between lubridate as that diff time, date, intersect, union. Okay, and it will mask this functionalities from the base function. Okay. Okay. So I just wanted to show that when we load tidyverse, it already comes with the other packages. So I don't think we have loaded before table or tidyr, etc. Okay. So let's go back here for our date. All right. So what's MDY? Okay, let's run this in our console. Question mark MDY. Okay, so it comes from our Lubridate package. All right, so Lubridate has a lot of functionalities. So here, parse dates with year, month, and day components. This transforms dates stored in character and numeric vectors to date or POSIX CT objects. So CTZ argument. Okay, so we have character or numeric vectors which can be converted into dates. Okay, so we have here the syntax, samples of the syntax. YMD, year, month, day, or YDM, year, day, month, different types of way to write your data. MDY is month, date, year, okay, etc. All right, then it gives us information about the arguments. And then let's see, we have an example here. All right, let's take a look at the example. Okay, here X is, we know that this is a character vector. And then this one, YMD, which is a function of lubridate. YMD, okay, so we have the syntax. Quiet is equal to false, time zone null, local, get local, truncated is equal to 0. Okay, so different syntax there, but the default is, okay, if you don't put anything there, then it will just run the default. So let's copy this. Okay, maybe just some of this as an added example. Okay, let's copy this. Control, let's copy one at a time. So this one, Control C, and let me just run that in the console, Control D. So here we have this object X. It contains this set of data, and then we will run YMDX. Okay, this function will convert, and why don't we include here class X? Okay, so let's run this, Control Enter. Okay, first we have this X, the class is character, and then YMDX, year, month, date. So it was now converted into year, month, and then day. And then let's take a look at the class of X. So X is now, oops, wait, YMDX plus X. All right. I should have placed here. Let me put here x is, let me just use x1 just to distinguish it. X1 is a ymd x, and then let's get the class of x1. All right, so let's run this. So what we did was to create this object x1, and then ymd of x, and then let's get class x1. All right, now we have converted our x into a date. You can see here now that x is a character and x1 is date. Let's print x1 there. Okay, so we have converted the vector x into a date object. Right, let's take a look at some other examples here. ymd, okay, what's this? Is it ymd? Okay, let's take a look at this. Control C, Control V. So first, this is x, and we're expecting this to be character. And then this one, ymdx. Okay, this is the same as the one before. Okay, and let's create another one, x2. This is the same as the one above. Okay. If I run this, you have x2, then it's also a date, same as the one above. And then about this one, what's ymd09? Okay. All right, so ymd 090101, we're converting it into year, month, day. So year, month, day. Okay, and then this one, what's this function? Now is greater than ymd 20090101. So the date, if we generate the date now, okay, this function now, it will give us, okay, it will give us both the date and the time and the GMT. This is what we call the standard time. So it's plus 08 because in Manila time, our time is the UTZ, Universal Time Zone. We are plus 8. No? Diba ang Manila plus 8 siya. So that's now. And then we run this. Yung now, okay, Control C, Control V. And if we're comparing now with year, month, date 2009, month, let's make it 12 December, day 31. So this is 2009, year, month, December 31. Okay, let's see. Let's make this, let's change this. 2024. Okay, 2024, December 31. Let's see if the date now is greater than this specific date. It will return false. Okay, because our date now is February 1, and February 1 is not greater than 2024, 12/31. Okay, you see dates are treated as numbers in R. So we can have this greater than or less than relationship. Okay, so let's go here. Okay, we'll have more on dates when we go to time series. Okay, so let's just work on what we have here. All right. Let's suppose we have we're creating this object birthday. and it's date, month, year. The date is 14, the day, the month is October, and the year is 1979. Okay, so let's run this. Let's say the birthday is birthday 1979, 10/14, October 14, UTZ. This is Universal Time. C is, I forgot the C. Universal Time, UT. And then, okay, we can get the month of the birthday. Let's run this. You can see that the month is 10. Okay, that's October. We can get the weekday. Weekday of the birthday label is equal to true. Okay. So what does this give us? So it tells us that this birthday was Sunday. Okay, and the levels are Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Okay, so itong month, itong date na to, October 14, 1979, it happened on a Sunday. So if you want to, for example, know what day you were born, you can use this. Replace this with your birthday and then use the weekday. Okay, of course, if we run the year, okay, year ng birthday is 1979. And let's see if what's the relationship between this one. Year ng birthday, here, ang sabi dito, make it 2016, no? The year of the birthday kanina, 1979. Tapos, ginawa nating, sabi dito, replace the year of the birthday with 2016. So if we check kung ano na yung birthday, the birthday is now 2016, 10/14. Replace na yung 1917. And the weekday will now be Friday na siya. Yung kanina Sunday, yung 1979. Pero yung 2016, okay? So, say, gawin natin ano, let's make this, let's create another one, Control C. I'll just run this here in the console. Birthday 1, if the birthday was, ngayon, date ngayon, no? 2023, day is 1, and month is 2. Kahit 1 lang yan. So, day, 1, month is 2, year 2023. Okay, so it's February 1, 2023. And let's get the weekday of our P-Day 1. So we expect, of course, that it should be a Wednesday, because you're Wednesday ngayon, no? Enter. And day 4. And we can write here the label is equal to, oops, sorry. Label is equal to true. Okay. Label is equal to true will give us the day itself. 4 here means Sunday is number 1, Monday is 2, Tuesday is 3, Wednesday is 4. So correct. It gives us the correct date, day to day. All right. So it's a Wednesday with 7 levels from Sunday to Saturday. Okay, a few more examples. Here, you have year, month, day. So you have this 2010, 12, 15. Okay, let's write this. Okay, so it tells us 2010, 12, 15. If it's year, date, month, should be YDM. Okay, so let's create this D1. D1 is this one. If we print D1, okay, it's 2010, 12, 15. It's a vector, right? A vector of a date. Okay. And then if I create D2, is this okay? D2, and then I make this into, I change the YMD to YDM. Okay, so we expect this to be 2010, 15, and 12, right? December 15, okay, enter. Okay, no formats found. Okay, see, it didn't run. Okay, kasi, ano sabi dito? Okay, YDM. Okay, nag-conflict siya kasi ang D1 kasi, YMD yan. So if we're making this YDM, okay, D1 kasi, the YMD, so hindi siya pa pwede, no? So let's just create another one, 20, let's say 2010, and then 15, and then 12. So same date, so D2, there you are, D2. So pareho lang siya, no? Pareho lang siya. So yung standard na pagsulat sa kanya is the year, the month, and the day. Okay, so we created this object D2, YDM siya. So in-identify natin na 2010, the day is 15, the month is 12. So when we printed D2, so tama. Okay, this function MDY HMS will add hours and minutes and seconds. Okay, and yung now, yung date now. There. Yung now, iko-kompleto niya, no? Yung date ngayon, tapos yung time ngayon, 12:06, and then yung time zone, which is +8 kasi ang Philippines +8 tayo. All right, so that's enough with the dates na muna. We will continue with that as we go along, especially when we go to time series. Okay, let's now have matrices. Okay, so the syntax for matrix is like this. Matrix, you have your data, number of rows, number of columns, and then by row, it's either equal to true or to false. N row is the number of rows. Okay, N column is the number of columns. So let's generate this. Okay, let's take a look at this. So we're creating this object A, and then we're imposing that it be a matrix. Okay, so the first part of this code is that we should identify the data. So here we have 2, 3, -2, 1, 2, and 2. Okay, so these are our numbers. And then we identify number of rows, okay, and then number of columns. So here we're stating that this set of numbers, 2, 3, -2, 1, 2, 2, it should be arranged in such a way that there should be 3 rows and 2 columns. Okay, let's first run this and let's have it printed. There. Now you can see that we have this object A. Okay, if you take a look at object A, it's in your data. It's a numeric data. So you have here 1 to 3, which means 3 rows, comma, 2 columns. And you see how it's and it falls under data. It does not fall under a vector, not values, but rather, just like in a data frame or in a list, it forms part of our data structure here. Okay. All right. So let's take a look at this. Now, how did R arrange this? So 2 and 3, -2 and 1, 2 and 2. Now notice Excel by default, R will default by default, it fills up the number by columns. Ba? 2, 3, -2, 2, 3, -2. Now, ganito yung arrangement niya kasi we informed R, we denoted that there should be 3 columns. So magsiset siya muna ng 3 columns, this one, and then of course, two rows. Definitely there will be 2 rows because 6 lang naman yung ano natin, yung objects natin. No? In fact, okay, let me delete this. Okay, sorry, Control Z. Let's copy this, Control C, Control V, and let's make it A1. And let's not write this. Okay, so what will happen? This is the number of rows. So if we specify the number of rows, and there are 6 elements here, then obviously, R will know that there will be 2 columns, right? Kasi 6 lang naman to eh. And then if we say that there should be 3 columns, then automatically, alam ni R na 2 rows yan. So take note of this, 2, 3, negative 2, no? Let's run A1. See, it's the same, di ba? 2, 3, negative 2 pababa, 1, 2, 2. Okay? Or, Control V. This time, let's make it A2. And let's not define yung rows. I blank the rows. Will we have the same object? Will it be this way also? I did not write the rows, okay, but I wrote the columns. Let's see what happens. Okay, si A2, yeah, pareho, di ba? It wrote it this way, pababa, 2, 3, negative 2, 1, 2, 2. Okay? So, same. Okay, once more. Okay, if I run this, okay, rinan din niya, no? 1, 2, 2. And there's this object A2 here. There. Although meron siyang question mark dito, no? Okay, missing argument to function call. Ibig sabihin, nasabi niya na hindi naglagay dito. No? Although generate pa rin niya yung ano yung. So, in order to avoid this, mas maganda na lang itong nauna. No? Hindi natin dinefine yung column, dinefine muna natin yung row, automatically, generate din naman yung result. Alright, then we ask what type of object is A. So class A, okay, matrix or array. Okay, is A matrix? Is that matrix? Will be true. Is A vector? Okay, false siya. And what will be the dimension of A? The dimension of A is number of rows, 3 by 2. Okay. Now, is it possible to write the data not vertically? Okay, we can do this. Control Alt I. Let's create another. And let's create another object. Let me copy this A1. Control C. Control V here. And let me call this A3. A3. And then take a look at this. We can write here by, okay, the syntax is, so the default is that the numbers are being written by column, right? You're going down. But if we want the data to be written as horizontally, then you have to impose that by row is equal to 2. So let's see this. Now take a look at how the data is now written. It's now going by row. 2 and then 3, negative 2 and then 1, 2 and then 2. So this is different from the object that we generate a while ago. Say A1. Is that A1? A3. Okay, so take a look at the difference. A1 is written going down, right? 2, 3, negative 2, 1, 2, 2. A3 on the other hand is written 2, 3, negative 2, 1, 2, 2. It's by row. It fills up the row first, and then so it goes from left to right. On the other hand, the default is it goes from top to bottom. Okay, so that's how a matrix works. All right. So I hope that's clear. Now we can multiply matrices. Okay, so here we're assigning the number 3 to letter C. So what if we multiply, where's our A? So we have matrix A, right? So what if we multiply C times A? Okay, sorry, I haven't run this. Let me run this. All right. Now we assign C, we assign number 3 to C. And then if I multiply C, a scalar, just one number with A, then I'm multiplying each of the elements in A by 2. Okay, so very simple. Just multiplying it by a scalar value. Okay. Now there are operations also in matrices. We have matrix addition and subtraction. Now you can only perform matrix addition and subtraction if they have the same size. Okay, so if you recall, what's the dimension of, let me just write that here, dimension of matrix A. So matrix A has 3 rows and 2 columns. Okay, 3 rows and 2 columns. Now let's create another matrix. Let's create another matrix called B. Let me just close this. Right. Let's create this matrix B. It contains 1, 4, negative 2, 1, 2, 1. It's also 3 by 2. Okay, and I'm not putting here by row is equal to true, which means that this will be generated going down. So we expect that our matrix, without writing it, let me annotate this. We expect that our matrix should be this one, right? So it will be 1, 4, negative 2, and then we have here 1, 2, 1. So this will be our matrix B. Okay, and matrix are usually written in brackets like this. So we have here B. A, so the size of matrix B is 3 by 2. 3 by 2 siya, which means that there are 3 rows. You first identify the rows and then the columns. So it's a 3 by 2 matrix. Matrix A is also 3 by 2. Therefore, we can add matrix A and matrix B because they have the same size. If matrices have the same size, then they can be added or subtracted. So here we're doing this operation. We're creating this matrix C, which is the result of A plus B. So can that be done? Yes, it's possible to do that. Also, this one matrix D is A minus B. Can that be done? Yes, also, because A and B have the same dimension, have the same size. Okay, so let me clear all the drawings here and close this. All right, so let's run this whole code chunk. Okay, there. Okay, so we have this matrix B. Okay, so let me again annotate this. So this is our matrix B. Okay, and then where's our matrix? This is A plus B. So A plus B. So if we add all the elements of A correspondingly, if you recall, okay, let me pause for a while here. Okay, let's copy our matrix. Where's our matrix? This is our matrix A, right? Okay, this one. just to be sure. 2, 3, negative 2. Okay, so our matrix A is 2, 3, negative 2. So if we Okay, 2, 3, and negative 2. And then 1, 2, 2. 1, 2, 2. If we add this A, this is matrix A. So we denote it by this brackets. And then A is equal to. That's how you denote a matrix. It's 3 by 2. And matrix B is also 3 by 2. So this is matrix B. Bracket here, bracket here. You can write here B is equal to there. So we can add this to matrix A. 1 plus 2, that gives us 3. 4 plus 3, that gives us 7. Negative 2 by negative 2, negative 4. Okay? And of course, you can subtract 1 minus 2. Okay, sorry. 2, this is A. 2 minus 1, that's 1. Right? 3 minus 4, that's negative 1. Negative 2 minus negative 2, that's 0. So this is your matrix D. Okay, so addition and subtraction of matrices are very straightforward. The only rule is that they should have the same size. Okay, if they do not have the same size, then we cannot add. Okay, let's suppose let's come up with another matrix. Let's call it J. Let's start with Z from the bottom. Okay, and then let's copy this. Control C. Sorry. So matrix. Let's just make it okay, 4 elements. 1, 2, 3, 4. Okay, so this should be 2 by 2. Okay, 1, 4, negative 2, and 1, 4 elements. So matrix Z is a 2 by 2 matrix. Okay, so let's run this. I'm going to run this. Okay, where did I make it? Okay, I think I have extra. So Z 1, 2, 3. There, matrix Z. All right, so 1, 2, 3, 1, 2. I'm still lacking 1. Okay, so we now have Z, matrix Z here. Matrix Z. It's a 2 by 2 matrix, right? Where's our Z? Below. I'm not finding Z. Did I run this already? Sir? My plus, I'm lacking something here. 1, 2, 3. 1. Where did I go wrong? C. Did I do anything wrong here? Okay. I'm having a syntax error. Let me just copy this. Control C. Let me replace my Z with this. Control V. And then I put here Z. Okay. 1, 2, 3, 4. So let me remove two numbers here. 1, 2, 3, 4. And then n row is equal to 2. And column is equal to 2. You run it. There. Okay. 1, 4, negative 2. Okay, so if we add, okay, if we add A, this is an operation, A plus Z. Is that possible? Can we add a 3 by 2 with a 2 by 2 matrix? Control Enter. Okay, error. Okay, it cannot be because this matrix A is 3 by 2, matrix Z is 2 by 2. Okay, all right. Now, matrix multiplication is more, let's say, complex compared to addition and addition and subtraction, because there is a rule by which we can multiply matrices. Now, we will need this when we go to multiple linear regression. It's important for us to understand how matrices are multiplied. So let me just give you the general rule. Okay, so let me annotate this. How do we know if matrices are multiplicable? So we're creating a matrix here, E, and it has a size 3 by 2, right? So E is a 3 by 2 matrix. That's how we denote this matrix, 3 by 2 matrix. And F is a 2 rows, 3 columns. It's a 2 by 3 matrix. All right. Right. So matrix E and matrix F are multiplicable if and only if you take a look at the column of the first matrix. Okay, the column is 2, and compare it with the row of the second matrix. If they're the same, 2 and 2 are the same, then these matrices are multiplicable. Yes, we can multiply them. And then the size of E times F will be this one. It's a 3 by 3 matrix. So we can multiply E times F. And take note, multiplication in matrices is not commutative. Unlike in algebra, where 3 times 2 is equal to 6, and then 2 times 2 is equal to 6. You can, commutativity means you can change the order of the multiplication. For matrix, let's try to see F and E. F times E. Now the question is, are these two, is FE multiplicable? So let's take the size of F, 2 by 3. And then what's the size of E? 3 by 2. Okay. Then let's compare the column of F with the row of E. Okay. So are they multiplicable? Yes, they're multiplicable. However, the size of the resultant matrix is 2 by 2, which tells us that E times F is not the same as F times E. Okay, E times F is a 3 by 3 matrix, and F times E is a 2 by 2 matrix. So 2 by 2 matrix will result. Okay, let me give another example. So let's suppose let's say A is 3 by 4, and B is 4 by say 2. Okay, the question is A and B multiplicable? Yes. Why? The column of the first matrix A is the same as the row of the second matrix B. Okay, 4, the same, and the resultant matrix is 3 by 2. So if we multiply 3 by 2, the resulting matrix is, if we multiply A with B, the resulting matrix is 3 by 2. However, if we try to get B, which is 4 by 2, and A, which is 3 by 4, you'll see that the column of B is 2 and the row of A is 3. They're not the same. Therefore, this is not multiplicable. So in both examples, class, we can see that matrix multiplication is not commutative, which means that we cannot change the order. In this case, E times F is 3 by 3. Yes, in this case, F times E can still be multiplied, but you have a different resultant matrix, 2 by 2. In this case, A multiplied to B is okay. The resulting size is 3 by 2, but B and A cannot be multiplied. Okay, so medyo iba, class, yung no? Iba yung yung matrix, no? So let me clear all the drawings. Okay. I will just continue my talk on this subject, class. You may leave at 12:30. You may have a class, but I'll just continue up to the end so that at least we have covered all the topics in this because it's almost time in this file. All right, so let's take a look at this. We have matrix E. So it's the same, matrix E is the same as matrix A, I think about. So let's generate matrix E and matrix F. Let's see. All right, so this is matrix E. See, annotate natin ulit. Matrix E is 3 rows and 2 columns, right? 3 by 2. And matrix matrix F, this is matrix F. This one, 2 rows, 3 columns, 2 by 3. Okay, 2 by 3. So are they multiplicable? Yes. 2 by 2 and 3 by 3. So the resulting size is a 3 by 3 matrix. Okay, so we will not go into the manual way how to compute this because it's quite long. So we will just know that these two matrices are multiplicable. Okay, let me clear all the drawings. And then let's generate this matrix G, okay, which we're multiplying. Let's try to see first, okay, F times E. I failed to write that. No? Okay, annotate again. Okay, what's F? The size of F is 2 by 3 here, 2 by 3. The size of E is 3 by 2, right? This one. 3 rows by 2 columns. 3 by 2. All right. So 3 and 3 are okay, the same. The size of F times E is 2 by 2. As I mentioned a while ago, E times F will have a size of 3 by 3. All right. So can they be multiplied? Is F times E multiplicable? Yes. And by the way, the function for matrix multiplication is percent asterisk percent. So this is how you write matrix multiplication. Okay, so let's multiply these two. Okay, Control Enter, and there we have our. This is our. This was our G matrix. So sorry. Oops. So this is our G matrix, G. Matrix G, which is F times E. And as expected, it's a 2 by 2 matrix. On the other hand, this is our H matrix, which we generated by multiplying E times F. And as we said a while ago, E times F, E is 3 by 2, F is 2 by 3. They're multiplicable, and the resulting mix is 3 by 3, which is this one, there. 3 rows by 3 columns. On the other hand, matrix G, which is F times E, is 2 by 2. 2 rows, 2 columns. Okay? So that's the rule as far as matrix multiplication is concerned. It's very easy to multiply matrix in R or even in Excel. Maybe when we go to multiple linear regression, we're going to look at this. We're going to need this when we generate our, we're going to learn how this is generated in a multiple linear regression. Okay, we're going to look at it first, matrix multiplication, and then we will use the functions in R. Okay, so let's take a look at this. Matrix J is 1 by 3. Okay, J is 1 by 3. Here, matrix A is matrix A is 3 by 2, right? 3 by 2. So are they multiplicable? Yes, they're multiplicable, and the resulting size is 1 by 2. Okay. All right. How about A times J? Again, A is 3 by 2. J is 1 by 3. Therefore, we conclude that A times J, this one, A times J is not multiplicable. J times A is multiplicable. All right? J times A, that's okay. The resulting size is 1 by 2. A times J is not multiplicable. So let me clear the drawings. Okay. And then let's run this first. I'm going to run J. So this is J. It's a 1 by 3 matrix. So let's generate K, which is J times A. Okay, so this is K. K is, as we said, a 1 by 2 matrix. And let's generate L. L, okay, error, non-conformable arguments. So A times J cannot be multiplied. All right. Then let's go to the transpose of a matrix. The transpose of a matrix is simply a matrix where the rows and columns are interchanged. All right. So let's run A. Let's print A. A. So this is A, right? This is the rows of A 2, 1, 3, 2, negative 2, 2. The transpose of a matrix will simply be the rows will become the columns. Okay, so therefore this column will become the row 2, 3, negative 2, and this one 1, 2, 2 will become the row also 1, 2, 2. So A, which is 3 by 2, will become the transpose of that will become 2 by 3, and the rows will become the columns, and the columns will be the rows, right? So that's just what the transpose means, and the function for that is this one, T. Okay, so let's create this object called AT, and that it's T of A, the transpose of A. Okay, right. So we now have this one, as I mentioned, 2, 3, negative 2, which used to be the column here, it became the row. Okay, and then if we again get the transpose, okay, here I'm getting the transpose of AT is the transpose, right? Okay, it will revert back to the original, because if we get the transpose of this, then it will go back to the original. So let's run everything here. Okay, run everything. All right, as you can see here, the original A is this one. This is the transpose. Then this is the transpose of the transpose. It just went back to the original. Okay, what's important here is the function T will give us the transpose of a matrix. All right, now these are common, okay, common vectors or matrices. So here we're creating a unit matrix. It's a matrix 1, 3, and then 1. Let's see what this will generate. Matrix 1, 3, and 1. Okay. So what do you have here? It's 1. It's 1. Okay. Object 1. And then you have by row is 3. 3 rows and column of 1. So this is what we call, this is a unit vector, right? All ones. And then a zero vector will look like this. Just the number is 0. 3 rows by 1 column. Okay, let's create this object Z. There. 0, 0, 0. Okay. All right. This is just a repeat. This one is 3 by 2. Okay, let's run this. So U1, you have 1, all are ones, and then 3 rows and 2 columns. And same thing here, 0 matrix, okay, 0, 3 rows and 2 columns, there, all zeros. All right. So let's take a look at the diagonal. So here we have 2, 3, negative 2, 1, 2, 2, 4, 2, 3. So how many elements are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 elements. So we're going to arrange it uh, 3 rows and 3 columns. So that's 3 times 3, that's 9. Then it will be arranged by column. You go down, right? So let's generate S. As you can see, it's arranged going down. 2, 3, negative 2, then 1, 2, 2, then 4, 2, 3. Okay? All right. Then let me get the diagonal of S. So the function here is diag, which is diagonal. So I'm creating this object called W, and then it's the diagonal of S. Then let me run this. There, it's 2, 2, 3. So you can see, let me run this S again. So the diagonal is this one, 2, 2, and 3. So you have a diagonal if it's a square matrix. A square matrix is a matrix where the rows and the columns are the same. So that's a square. 2, 2, 3. So W is this one. Now, can you get the W1 is, you can write here diagonal of W, or the diagonal of the diagonal of S. The diagonal of S is 2, 2, 3, right? Now, can we get the diagonal of, so let me run this, 2, 2, 3. Now, let me get the diagonal of W. So, is it possible to get the diagonal of this 1 by, of, okay? So here, what do we have here? So, the diagonal of W, okay, so we identified W to be 2, 2, 3. All right. So we let W be the diagonal, and we did not mention any elements to that. Okay, so take a look at this. The rest are 0, and 2, 2, 3 is the 2, 2, 3 is the diagonal. Okay, the diagonal is 2, 2, 3. The rest are 0. So we created this W1, and W1 is of course a matrix here. Okay, and the others, other elements there do not have anything. All right, then we go to the identity matrix. All right, identity matrix is a type of matrix where all the elements are 1 and the rest are 0. It's just like here. So we can use the diagonal function, and we will, here it says the diagonal is 1 and 1 row, okay, 1 and 1. So what will this give us? 1 row, 1 column, okay, call it 1. Okay, okay. No, wait. 1, 1 here. Okay, sorry. The diagonal is 1, 1, 1. Okay, so we have the diagonal here. 3 elements, 1, 1, 1. That's our diagonal. Unlike this one a while ago, the diagonal is 2, 2, 3, right? Here, the diagonal is 1, 1, 1. Take a look at this. 1, 1, 1. So this is what we call an identity matrix. It's actually called an I3. I3 because it's a 3 by 3 matrix. Okay, it's a 3 by 3 matrix, and then the diagonals are 1 and the rest are zeros. Okay, let me create another one. Let's say I5. I5. So diagonal C. Okay, 1, 2, 3, 4, 5. So all the diagonals are 1. The rest will be 0. Let's print I5, Control Enter here. It's an identity matrix. Okay, the size is 5 by 5. Now this is very important because an identity matrix, by the way, those of you who need to go, it's okay, you need to go. Even if no one is left, I'll just continue. Anyway, I'll I'll be, it's almost over. So I'll post this anyway. All right. So let's take a look at this. What's a symmetric matrix? So here we have 2, 1, 5, 1, 3, 4, 5, 4, negative 2. So we'll create this object called L. matrix, and then we make this 3 by 3. Let's run this matrix. So this is L. If you notice, you have this diagonal 2, 3, negative 2, and you see here the elements are mirror images of each other. So row 2, column 1 is the same as row 1, column 2, 1 and 1. Okay, this one, 5 and 5, and then 4 and 4. So this is the diagonal. The the elements outside of the diagonal match each other. 1 and 1 are the same, 5 and 5 are the same, 4 and 4 are the same. So if we get the transpose of L, so let's create this object called LP, and then we get the transpose of L. Let's run both. Okay, so this is L, and this is the transpose of L. They're exactly the same. We call them symmetric matrix. Okay, so even if you get the transpose, you'll still get the same answer. So a symmetric matrix can only be a square matrix, which means that the number of rows and the column should be the same. Okay, but not all square matrices are symmetric. Okay, how about the inverse? So let's identify the inverse of a matrix. This is very important. Okay, so let's create this matrix. Okay, let's create this matrix. Let me call it J, okay, or M. Let me just change the name because we already have A. M is a matrix 4, 4, negative 2, 2, 6, 2, 2, 8, 4, 3 by 3. Okay. Sorry. All right. So this is our M matrix. Okay. So let me create an object called M inverse. Let me call it MI, and then the function is solve M. So this will to generate the inverse inverse of a matrix. Okay, you cannot generate the inverse of a matrix if it's not square matrix. A square matrix is a matrix that has the same rows and columns. Okay, so we use the function solve in order to get the inverse of a matrix. So let's run this line, Control Enter. All right, so you can see this is the inverse of M. This is matrix M. This is the inverse of M. Okay, and we're not going to learn how to solve this manually because it's a tedious procedure. Okay. Now, what's important about the inverse of a matrix? Okay, by the way, not all matrices, not all square matrices are invertible. When I say invertible, you can get the inverse of a matrix. Some square matrices cannot be invertible, or you cannot get its inverse. But if the matrix is invertible, okay, let's call this M. This should be M and MI. This should also be MI with M. What happens if we multiply the matrix M and its inverse? Let's take a look. By the way, are these multiplicable? What's the size of M? Let me just comment it. Okay, let me just annotate. What is the size of M? Matrix M is 3 by 3, right? And MI matrix M inverse is also 3 by 3. Okay, the inverse of a matrix will always be the same size as the matrix. And since you cannot invert a matrix that's not a square, it will always have the same rows and columns. And the inverse will also have the same rows and columns. All right, so this is definitely this is conformable, and the resulting matrix, okay, is also a 3 by 3 matrix. Also, the inverse multiplied by n. So this is 3 by 3 multiplied by 3 by 3, then that's okay. All right, so let me clear all the drawings and then close this. All right, let me first multiply this m by m inverse. Okay, let's multiply both. Control enter. Okay, what do you notice? Any matrix that's invertible multiplied by its inverse will always give us the identity matrix. So remember, this is identity, right? Identity matrix, where the diagonals are 1 and the rest are 0. And also, the inverse of a matrix multiplied by the matrix is also an identity matrix. Okay, so this is a very important law or principle as far as matrix algebra or matrix multiplication is concerned. Okay, so if a matrix is invertible, if a matrix is invertible, then when we get the inverse of that matrix and multiply it to the matrix, then we get an identity matrix. Okay. All right, then just a few more things here. Okay, let's go to the inverse and the determinant of the matrix. So this is another example. You have matrix C. C is a matrix. We have 2, 1, 6, 1, 3, 4, 6. And let's create a 3 by 3 matrix. So this is our 3 by 3 matrix. Let's get the inverse of matrix C. Okay, let's see. All right. So this is the inverse of matrix C. Okay. So if we multiply C with its inverse, we should get an identity matrix. Okay, let's multiply. Let's run all this code chunk. There. So what do we get here? We have here, this is the matrix. And this is, and this is what? And this is the inverse, supposedly the inverse of the matrix. However, what we get here, when we multiplied C with its inverse, what do we have here? This is, well, these are practically zeros. No? Let's just put here around round. Let's see if this will run. And let's not put any decimal place. Okay, let's see. Also this one, round, because you can see here that there are decimal places even to the 17th, which is practically 0. So you have here 1, and then you have here, this one is 5.55 times 10 to the negative 6, 17, which means 0.5, and then the first point, and then 16 zeros, and then 5. So that's practically 0. Let's see if we can use the round function here. Okay. Oh, wait. Right, this one also. Round. Let's round the answers to no decimal places, or for this one, let's make it 2 decimal places. At least for this, and let's see. All right, take a look at this. So this is matrix C. This is the inverse of C. This is C times the inverse of C. This is the inverse of C times C. So this proves that this matrix C is indeed invertible, and that we have shown, and this is the inverse of C, and we have shown that the matrix multiplication of C and its inverse is an identity matrix, and the inverse of C times C itself is also an identity matrix. All right. And then, okay, this one, you have also the concept of the determinant of a matrix. If you run this, I'm creating this object D, all right? And we have this determinant of a matrix, all right? Determinant of a matrix is C. Okay. In general, if the determinant of a matrix is non-zero, then that's invertible. Okay, it's invertible. All right. So for this, just last two. Okay, we have horizontal concatenation and vertical concatenation. Okay, maybe let's just before I end here, maybe I'll just let's take an example of a non-invertible non-invertible, I forgot to put this, matrix example here. Let's take a look at a matrix that's non-invertible. What are some examples? Let's get an example. Okay, I don't see any example here. Let's take a look at here. Oops, that's one. I hope they give an example here of a non-invertible matrix. Okay, let's let's use another example. Okay, sorry, I forgot to put here. Okay, here, this one. This one looks good. Okay. Please give me an example. I'm not finding one. Sorry about that. Okay, let me change example of a matrix of a non-invertible matrix. Okay, maybe here. Okay, this one plus. So 1, 4, let me just write that. 1, -4, 2, -2, 1, 3, 2, 6, 8. Wait. Invertible matrix. This is invertible. All right. It's not giving us a okay. Here. Oh, yeah. No. This is invertible. This is invertible. What we need is an example of a non-invertible matrix. Sorry, I wasn't able to. Just as an afterthought, I think I it's in my 2 times 5, 10. 16, 6, this one. Okay. 2, 4, 4, 8. Okay. That one. So let's generate this matrix. So let's call this, let's call it R matrix, R, okay, so it's matrix, and then C, 2, 2, 4, 2, 8, 2, and then 4, and then 4, 8. Okay, and then let's say 2 by 2. All right, let's take a look at this matrix. Matrix C is 2, 4, 4, and then let's print it. Okay. All right, so this is non-invertible. All right, let's get the, okay. First, let's get the, this one, the inverse of the matrix. Control C, so that your Control V. Let's get the inverse of matrix R. Okay. This is how to get the inverse. Solve R. Okay, enter. Look, take a look at this. So it's telling us that this matrix is non-invertible. Okay. And why is that so? If we get the determinant of matrix R, okay, just like what we did here. Okay, notice that it's 0. So if a matrix has a determinant equal to 0, then it cannot be, it's not invertible. So you cannot get the inverse of that matrix. So that if I, for example, if we multiply that matrix, let's use this. Control C, Control V. So let's try to multiply matrix R with its inverse. Right? Now we know that matrix R inverse does not exist. Okay? If we multiply that there, Ri not found because we were not able to generate this, the inverse of a matrix I. All right, and lastly, okay, so this one, we're generating this matrix P. It's a 3 by 2 matrix, and this is matrix Q. It's also a 3 by 2 matrix, and we can concatenate them. We can generate this object H, and then we're going to C bind them. Okay, so let's run this. All right, so this is matrix P. 2, 3, negative 2, 1, 2, 2. It's always going down, unless we say it's by row is equal to 2. And then matrix Q, okay, that one. And we can column bind. We're creating this object H, where we are binding P and Q. So we have this matrix P, which combines matrix H, which combines matrix P and matrix Q. Or we can R bind them. Okay, here we're creating this matrix B, where we're going to bind, okay, it should be R bind P and Q. P and Q. Let's generate this. All right. Here what we did was to row bind it. Okay, this is matrix P. And then we put below through the row matrix Q. A while ago, it was C bind, column bind. Here, this is matrix P, and then we put in the column matrix Q. Okay, so that ends our discussion for matrices. There are some activities here, exercises. I hope you work on that. Okay, in this exercise portion. Okay, so let me stop our recording for today. Stop.